Unit 7.4, Developing Algorithms Using ArrayList. So right now, we're going to do these things right here. We're going to create an array of customer account info, create an array list of bank accounts, insert objects into a list in alphabetical order. We're going to do that by last name, delete objects from a list with a specific last name. And if you remember, the bank account was done in Unit 5, so just a quick reminder, this is the way the data was organized in the constructor. The account number is first, the balance, the last name, the first name, address, phone number, and email. So clearly I had to do an import. Let me go up to my imports. Here it is. Imported it from Unit 5, but I imported a bunch of other things too, some of which are not on the AP exam. A tree map, a string tokenizer, an iterator. Although they're not on the AP exam, they're still good to know. And we're not going to limit ourselves to the AP exam information. We're going to learn some more. So here we have the account info in a static array. Okay, and the information is separated by commas. So the first piece is the account number, comma, balance, comma, last name, comma, first name, comma, address, comma, and so on. Just like it is up here. So this is the actual data that's going to be used to create the account. So I have down here a list of accounts. Also static array list of bank accounts, not strings. Okay, these are strings, just the raw data. This is the bank account. So we're going to create the bank account using the non-default constructor after we get all these pieces stripped away from here. To do that, I'm going to sort it with a method that's called sort account info. It's a private helper method. When you see a method private, it means it's callable inside this class, not outside. So I don't want to call this outside. I want to call this inside the class because this is going to help me create this bank accounts list in alphabetical order based on last name. So a tree map is here. So a tree map is new, right? The tree map is simply a data structure that has a key value pair. Okay, the key in my case is a string and the value is a bank account. It could be any two things you want here, but it must be a key and a value. Now the way this works is that the key and the value is a unique mapping. One key, all the keys are unique, mapping to one bank account. That's the way mine is set up. Now you could do a lot of different flavors of this, but this is how mine is set up. Now this is not the best way to do it because this key needs to be unique, and if two people have the same name, you can run into trouble. But for now, just an illustration. So I'm using the first and last name concatenated, put together to make my key. And the bank account is going to be all this information that was encapsulated in my bank account object using its non-default constructor. Now, what's important about this tree map is that it naturally sorts things. And one of the things it can sort definitely is strings. It sorts them based on their keys. So that means after putting all these into the map, it's going to take the guy whose last name shows up first alphabetically, and he's going to be the first guy in there, and the next guy is going to be after him, and so on. So I don't have to actually write a sorting algorithm. I could just use this, and he'll do it for me naturally. So first I come up on a for each loop inside this method, and it's for each info in this account info up here, this guy, for every info. So for each one, this whole first piece here will be the first one. I'm going to come across a new thing, a string tokenizer. Well, remember that comma separated file, or the comma separated data points? Now, this is called a delimiter. The comma is called a delimiter, okay? And the delimiter means what's being used to separate the data points. So it's a comma. So this guy is able, a string tokenizer is able to separate this string with commas based on the data points inside the string that are separated by these commas. So what that means then, it could pick out the account number only, because it knows when it sees the next comma, what follows is data. So it picks out that, and then it sees a comma, so it knows where the data begins and where it ends. So it could say, oh, comma, data is about to come. Bang, got that data. Oh, comma, next data is about to come. Bang, when it sees a comma, the data is over. So it grabs the next one. It's going to keep going like that. Nice structure there, nice little tokenizer. So what I did is I create all the pieces for my account, right? Remember, account number was an int, balance is a double, and then all the others were strings. So what I'm going to do now is I'm going to create an index because this tokenizer is not indexed. So I'm going to create an index. Why? Because I want to know where I am. If I have a 1, see, I'll use a switch down here. So I'm mixing up all my different pieces from before. If I see a 1, I know it's the first guy. So that's going to be my account number. And then 2 is going to be my balance and so on. So I have this index to do that for me. And then I come across a while loop. So I see we have a for loop outside who's processing all of these information. Then I have a while loop inside who's making the bank account. Okay. So when I ask this guy, do you have another token? Has more tokens. Tokens are the data points. So for example, the account number is a token. The balance is a token. The last name is a token. So it says, if you have more tokens, get the next one. So you should say, wait, the next? Yeah, that's because when this thing first start off, it's going to look in front. Tokenizing and iterators are very similar. It's going to look in front. So it's going to peek over. Do you have another one? It's going to say yes. So it grabs the first one, which is the account number, and stores it as token. Then I'm going to switch on the index. See what I did there? I updated my index plus plus because this is going to be 0 for each of these. When we start, it's going to be 0. Then I'm going to update it, so it's going to become 1. Then when I switch on the index, it's going to look for case 1 because this is a 1. And it's going to take the first token, turn it into an integer, and store it as the account number. Break. Okay, so my breaks are being used. Every single one of these things are specific to the data points. And so I come back, say you have more tokens, says yes, it's going to go across and it's going to grab the next token, which happens to be the balance, goes up by 1. So I'm looking at case 2, grab the balance, double dot pass double. I like how everything is kind of tying in here. It's like all the old stuff meets some new stuff, very nicely written how I have this, so I could walk through and see how everything's working. Then it goes back. Has more token? Yes, it does. Grabs the next token. That's the last name. Do you have more? Yes, the next token is the first name. It's going to keep grabbing and assigning until it gets to the last token, which is the email. Then it says, has more tokens? No, it does not. Comes down, and then there are 3 lines of code. Look at these 3 lines of code. First, make a bank account using the non-default constructor, taking each one of these data points that I just stripped off. So I'm going to put the account number in. Remember, this is for one account. And then go input the balance, last name, first name, address, phone number, email, make the account. Then I make the key. Let's highlight the key here. Because remember, the map needs a key. Take the last name plus the first name, make a key. Then put them in the map. Okay? Put them in the map. So this map, how does it sort these things? Like, how does it? Okay, then we come back up here, and then it's going to run the second account, right? So this is going to happen again and again until all the count information is finished. But how does it sort these things into a map? Well, let's take a look at the map. Tree maps, not a linear structure. I know we're going to do this a little later in the course, so not to worry about all the specifics per se. I'm just going to tell you these are nodes. Okay, these are nodes. We're going to talk a lot more about this later. And the tree is upside down, so the root's at the top. Okay, the root's at the top, and then it has branches, obviously. You can see how it's branching off. Now you can see this guy over here on the left. The way tree maps work, and I'm only going to focus on tree maps for now, is that they are naturally ordered. And these numbers are showing the ordering, okay? So this guy over here is the first node. The second node is here, okay? The third node is over here, fourth and fifth. Now, it may not look like it's in order, but it is in order going from left to right. Think of it as if I'm walking going from left to right, which node do I bump into first and which node do I bump into second, okay? As if you were doing a scan. Like if I put a whole scanner here, or a big scanner, and I sliding it across, boop, hit the first one, boop, hit the second one, that would be this guy. Then boop, hit the third one, this would be this guy. Boop, hits the fourth one, which would be this guy. Boop. So the order looks kind of like this. 1, 2, 3, 4, 5. I know it looks kind of weird and jagged like that, but that's how trees are. They're not linear structures. They're non-linear structures. So traversing them is a little different as opposed to an array list or something like that. But this is how the tree map works. So it automatically puts my names in order just by me calling put. Okay. And then because of that, I could then, when it's all finished, send back the map. Okay. And that map that I sent back, you can see I had it printed here to see how the map looks to make sure everything is fine. And it was fine. And then once that map comes back, it comes back as a map who has the last name and first name together as the key and the bank account as the value. So what do? I then write the method that is exposed, the public method that you can call outside of this class. And the first thing I do is say, hey, sort the information for me. And it sends back a map, and I store the map. It comes back as string bank account map. Then I write a for each loop again. So I'm using all the pieces. I'm purposely writing this so you can see all the things that we did in isolation put together to write a nice algorithm. Get the map, get all the values, add them to the account. I could have done this all at once, but I broke them up into two, and the reason for that is on the AP exam, they could ask a question like this, of course, not with tree maps and string tokenizers and so on. They could just write this private method and say sort account. Okay? So it could just sort. So you have to then say, oh, and it's going to say inside here, implementation not shown. So you're going to have to go and call the sort, get the information, then use it. It might not be exactly the way it is here, obviously, but that idea of they made a method that you're supposed to call, and then you're going to use the information from that call to do what you need to do. That's definitely one of the things that they test every single year. So I did this with that in mind. But I did the implementation also for you to see new things and learn something new. And no, but this tree map is not the only map. There's also something called a hash map. There are a lot of different data structures, and we're going to see a few of them near the end of the course. The next method that I did, our algorithm, is to remove all the accounts in the same accounts list here. Okay, that global guy. Remove them with a particular last name. So give me a last name, and once that last name exists, I'm getting rid of them out of the list of accounts. So how does this work? Well, I did this because I wanted to reiterate. When you're removing from a list, you need to go backwards. And I'm going to make that like a theme here. See? I'm starting at size -1. Stopping at 0, greater than or equal to 0. I said that this is so often used and so often it's so frequently used that you got to know this. Like you could even memorize it. The name of the list, dot size -1, I greater than or equal to 0, I minus minus, go backwards. How do I do it? I grab a bank account from the list. I ask the bank account, is it equal to the last name? Get me a last name. See the getter? See, this is in the bank account. Remember, the getters need to be public, so I could call it. Hey, get me a last name. Is it equal to? See how this says content equal? This is an update in the API. We could also just use equals. Both work just the same way. Is it equal to the last name? Yes. If it is, remove it. Okay. Now you realize that because this is removing, I couldn't use a for each loop here, right? Because concurrent, right? Remember that error? Can't remove things and update the list and use a for each. This doesn't work. So you need to use eyes. Yeah, keep removing, and then when this loop's finished, send back the accounts. It will be completely free of all those specific last name accounts. So I'm going to go ahead now and jump down to my main method, and I'm going to click a quick run on these to make sure that they're working. So let me slide down. Here we have them. So what do? Well, I printed so that we could see, where the printout for this particular unit starts. So we have some space there because we have a lot of things printed. Now I call the last name stuff, right? It's a static call. See, unit 7 dot do this. Save them as bank accounts. Now these are going to come back with the bank accounts in correct order by last name. Then I print them. Then I do some printing here to create some space, and then I remove all the hope. Okay, remove all hope. The hope, any last name hope is going to get out. And when I print it again, we won't see hope. So let's go back up and check before we run it. You could see that some of these last names are hope. See, hope's here. But only 1 and 2, Maria and Alice, should be out of the list by the time we are done. But the first time we should see all of them in alphabetical order. We're running that. And let's pull this up and take a quick peek. So let's go down and find them. So we're looking for the accounts, and here they are. So last name Gail was first, and then Grace, that's the G's, and then Griffin, and then Hope, right? and A, B, C, D, E, F, G, H, I, right? You could tell that we're in alphabetical order. And then we made a little space because we're going to remove the hopes. Okay, so we shouldn't see Maria and we shouldn't see Alice. Let's run down, run down, run down, run down. There we go. Don't have any hope. Okay, no hope is in this one. So we only have the rest of the accounts. Again, this is simply writing algorithms using the array list. I did a lot more than that's on the AP exam, but it's also good to really focus in and get something new. So really do check out the tree map, and if you want to go ahead and check out hash map as well and see how these tokens work, because this is a nice thing to do, especially if we have data in a database or also in some file somewhere, which we should have done, but I didn't want to make that too complicated and add extra stuff on it. I want us to really focus on what we're doing here so that we could pull information out and create objects from them. And this is a nice way to go ahead and do that. Now you hear as I have a helper method. Then I have the main method that we shouldn't say main method, I should say the add in last name order method, which is the method that we really focused on to get done. The helper normally on the AP exam is not shown. It's normally shown as some kind of, method there. You could use it. You may use it, what they're saying, which means must. And then we could see how to remove. As a quick recap, we need to go backwards. Please go backwards. If you're going in an array list and you're moving something, go backwards. That would bring us to the end of 7.4.